Hi class, in lesson 1 you will be writing equivalent expressions using the distributive property. Learning goals for today: write, read, and evaluate equivalent numeric expressions. Identify the adjacent side lengths of a rectangle as factors of the area value. Identify parts of an expression such as the product and the factors. Write equivalent numeric expressions for the area of a rectangle by decomposing one side length into the sum of two numbers. And apply the properties of operations such as the distributive property to rewrite the product of two factors. Key terms to look for in Lesson 1: numeric expression, equation, and distributive property. Please turn to page 9, Activity 1.1, Connecting Area Models and the Distributive Property. Consider the equation 5 times 27 is equal to 135. An area model to represent the product of 5 and 27 is shown. The area is 135 square units. Let's think about other ways to represent this area. Please answer number 1 and number 2 with your groups. For number 1, here is one example that you could have to split the area model into two parts to represent the area of 135 square units. The dimensions for the first rectangle would be 14 by 5, and the dimensions for the second rectangle would be 13 by 5. For number 2, the sum of the area of the two smaller regions or rectangles is equal to the total area of 135 square units. Please answer number 3 with your group members. For number 3, here is an example of how you can rewrite the original product by substituting the sum of the two lengths making up the split side. For number 3, letter B, here is an example of how you can rewrite the total area as the sum of the areas of the two smaller regions. Think about other ways you could split one of the factors and write a corresponding equation. What would the equation look like if you split one of the factors into more than two regions? Please answer number 4 with your group. For number 4, here are two more ways that you could divide the area model, and here is an example of what the area model would look like if you split one of the factors into more than two regions. Please answer number 5 with your group. Using my area model from the example above, 5 times the quantity of 16 plus 11, I split the side length of 27 with 16 plus 11, the factors in each of the smaller regions, 5 times 16 plus 5 times 11. 5 times 16 is going to give me 80. 5 times 11 is going to give me 55. The total area is 135 square units. Please turn to page 11. On the previous page, you just used the distributive property. The distributive property of multiplication over addition states that for any numbers a, b, and c, a times the quantity of b plus c is equal to a times b plus a times c. Here is another example of the distributive property. 4 times the quantity of 2 plus 15 is equal to 4 times 2 plus 4 times 15. Please answer number 7 with your group. For number 7, here are the 3 area models, the equations for the 3 area models that I created in this activity using the distributive property. Please turn to page 12, Activity 1.2, Interpreting a Real-World Situation Using the Distributive Property. Tyler is setting up the gym floor for an after-school program. He wants to include a rectangular area for playing volleyball and another for dodgeball. He also wants to have an area for kids who like to play board games or just sit and read. The gym floor is 50 feet by 84 feet, or 4,200 square feet. Please answer number 1 with your group. For number 1, here is an example of what your diagram could look like and how you can use the distributive property. We have a rectangle of 50 by 84. 50 times a quantity of 10 plus 34 plus 40 is equal to 50 times 10 plus 50 times 34 plus 50 times 40, which is equal to 4,200 square feet. This will conclude today's lesson on writing equivalent expressions using the distributive property. Please let me know if you have any questions. Thanks.